For example 1, I'd like to not just factor a trinomial, but also solve an equation. So where is x squared plus 10x plus 24 equal to 0? So one approach you could take is just by trying to guess, like plug numbers in place of all the x's and see if you get 0 on the left side, meaning it'll be equal to 0 on the other. But a better approach is actually to factor the expression. So let's start there, where we'll take the x squared plus 10x plus 24, we'll factor it, and then set that thing equal to 0. So again, our approach being, I'll look at the 24, and I'll think of factors of it that are going to add to a positive 10, and 4 and 6 should work. I'm going to fill all that in. That's going to be x and an x. Everything is positive, so it should be plus 4 and plus 6. I know the product of these two things will give me my x squared plus 10x plus 24. So how does this help us figure out where this equation is equal to 0? Well, since these two pieces are being multiplied together, if this piece right here is equal to 0, and you multiply it to this thing, 0 times this whole thing is still equal to 0. So it kind of like makes the problem a little bit easier to think about. I can now just focus on x plus 4 instead of this bigger expression here. So I'm just going to copy down x plus 4 and ask where is that equal to 0. That's pretty easy to solve. It's where x is equal to negative 4. So I'll be really careful here, but if I plug negative 4 back into the expression, so we get negative 4 plus 4 times negative 4 plus 6, is this equal to 0? And it is, because we get 0, and we also get 2, but again, it's like, who cares? I know that one of the factors is 0, so you'd still get 0 is equal to 0. I don't think we have to check this every single time. I mean, if we do the same thing for x plus 6 and set that equal to 0, I know that negative 6 is the solution that gives me 0. It's going to make the entire equation equal 0. So the answer to this question is x equals negative 4 and also negative 6. So if you're dealing with a trinomial, break it down into a product and figure out where each product is 0, and you will get these two solutions here. Okay, same idea in example 2. I want to solve this, what's called a quadratic equation, something that has an x squared in it. So where is 6x squared equal to 5 minus 7x? Well, if we're wanting to use the approach that was in the previous example, what made that easy was one side was equal to 0. So that's going to be my first step here. I want 0 to appear on one side of my equation. So I'm actually going to take the 5 and the 7x and move them to the other side. So I'm going to rewrite the equation to 6x squared. I'll add 7x to both sides. I'll subtract 5 from both sides, and then I get 0. This is a good approach if you're going to use a factoring technique. Make one side equal 0, and then factor the other side. All right, so we want to factor 6x squared plus 7x minus 5. Again, you could use a factor by grouping approach if you wanted. You could also just try to guess the answer by looking at the 6 and the 5. And like the factors of 6 are 1 and 6, or you could use a 2 and a 3 if this problem's going to work out nicely. 5 is even better, so it's going to be a 1 or a 5. I see there's a negative there, so one of them would have to be negative. So the rest is just sort of guessing. And let's see. I'm going to guess that's probably not 1 and 6. I'm going to go with 2 and 3. So to start this problem, I'm going to put a 2x and a 3x. I mean, it could be x and 6x, but I'm thinking based on the numbers I'm seeing in my expression that I'd like the values in front of the x's to be closer together, so I just went with 2 and 3. So the next thing is going to be, well, I have to have a positive and a negative, and so this part's just a guess, so I don't know, maybe it's positive and negative. And if it's wrong, I'll come back and switch it later. But now I need a 1 and a 5. So I'm, again, just going to guess. I'm going to say 1 and 5. And now I'm just going to check to see if my middle term works. Will I get a positive 7 for my middle term? So I do 2 times negative 5. Okay, that's going to give me negative 10. And I'm going to get a positive 3. So actually I get a negative 7 instead of a positive 7. But that's actually really great news. I think if I just switch the sign on both of these terms, then it should work out. So let me get rid of this and that and switch it around. So I'm going to say I'll go negative and positive. And let's check to see if that works. We get a negative 3x, a positive 10x. That definitely goes back to a positive 7x. All right, great. So I was able to quickly guess the solutions for this one to factor it. Now what I do is I look to each factor and I ask where those are equal to 0. So I have, where is 2x minus 1, 0? And where is 3x plus 5, 0? So if I add 1 to both sides and divide by 2, I get 1/2. If over here I subtract 5 from both sides and divide by 3, I get my two solutions. They are positive 1/2 and negative 5/3. Those two values, if you go back to your original equation, will make the left side equal the right side. And for the last example, same idea. I just want to solve an equation. This one, even more complicated than the last one. It's not quadratic anymore because there's an x to the 4th, but same idea. I want to make one side 0. I'll factor the other side, and then look at each individual factor to see where it is 0. All right, I guess I'm just going to subtract 105x squared from both sides. So I'm going to write this as 75x to the 4th minus 30x cubed minus 105x squared. And that's now equal to 0. If I scan across each of the three terms, I see that, oh, well, I can take an x squared from everything. And 75, 30, and 105 definitely have a common factor. So I'm not sure what it is. I mean, a 5 definitely comes out, so maybe I'll start there. I know I can remove a 5 and an x squared, and I'm just left deciding what is left over after I do that. Okay, so I am left with a 15x squared minus 6x minus 21. And okay, all right, so there's still a little bit more that I can take out. I see there's a 15, a 6, and a 21, and there's a common factor of 3 from every single term. I think that's the most I could take out from everything. If I remove a 3 and place it here, this will become 3 times 5, or 15x squared. And I removed a 3, so I have 5x squared minus 2x minus 7. And now I'm left factoring at least something that's a little bit easier to deal with. 5x squared minus 2x minus 7. Well, I mean, in terms of the 5, I mean, that's going to be simple, right? It's got to be a 1 and a 5, and then a 7, it's going to be a 1 and 7. Those are both prime. There's a negative, so I just have to put the right negative in the right spot. So let's take a guess and check approach where, okay, I have two factors. I have to have a 5x and a 1x. And then it's positive and negative, and I just want to put the right value so I get a -2 in the middle. If I think ahead a step, I'm going to put a +1 here because the 5 is going to go to that 1. If I put a 7 there, it's just going to be 35. I don't think that's going to take me to a -2. but by this choice, I now have to do -7 here. And let's see. All right, that's going to work. I have a -7. I have a +5, which balances to -2. So this whole thing factors my original equation here. But this time's a little bit different. I actually have 3 factors now. I have 5x minus 7, I have x plus 1, but I also have this x squared here. So if I focus on just these 2 pieces, I have 5x minus 7 is 0, and I also have x plus 1 is 0. Well, I know -1 gives me a solution, and I know, well, 5x is equal to 7, so x is equal to 7/5. That's a solution as well. But this thing, this 15x squared equals 0 gives me a solution as well. Like, I divide both sides by 15, I get x squared is 0. And I can just look at this and know that, oh, well, if x squared is 0, then x equals 0 must be a solution too. So I have 3 separate solutions. The 2 that appear here are as we've seen before, but this one works too. You probably could have even guessed this if you looked back at the original equation, this thing here. If you put a 0 in place of every single x, clearly the left side is going to be 0, and so is the right side. So it's good that we actually ended up with this thing here. Well, we have 3 solutions, and that is it for this example.